Hi, this is the fourth part of the topic factors of quadratic expressions. Here we will try to find out the factors of quadratic expressions that involve negative signs. In part 3 of this series, I had given you certain expressions that involved negative signs. So we need to find out if the technique that we developed for expressions involving positive signs works for these expressions too. So I'd asked you to solve these on your own. Try to see if the same technique can be used. And I also given you hints on how to solve these. Hope you have tried solving these quadratic expressions. So let us take an example with a negative sign. The quadratic expression is x squared minus 3x plus 2. So let us first try to do it using the practical method, which involves the square shapes and the rectangular shapes. And then we'll try to see if our technique can be used on these expressions also. So for this expression, you need one piece of area x squared. And what about the minus 3x? How many pieces of x do you need? You need 3 pieces of area x, and those need to be subtracted. So instead of x, we'll turn it over and make it minus x. So in the pieces that you have created, you can color the other side of the piece using some dark or black color, and then mark it as minus. So these pieces need to be removed from the area, and then we have 2 pieces of area 1. So is it possible for us to make a rectangle out of these? So let us try to create the rectangle. So we have one piece of x square, we have 3 pieces of x minus x, and 2 pieces of 1. So let us try to see if we can form a rectangle. So I have subtracted minus x from x square. I'm subtracting one more minus x and the third minus x. So now this part is a rectangle. So if I had only x square minus 3x, I would have got a rectangle, but I still have the 2 pieces of area 1. So where do I fit them? Let us see if I can fit them somewhere. So if I fit them here, I still don't get a rectangle, because here I get a L shape, which is not a rectangle. I could also try to fit it here, but still I don't have a rectangle. So what do I do now? So let us see. So we'll remove this, and we'll remove the pieces of area 1 also. So can we fit this one piece of minus x somewhere else, so that we can fit the other 2 pieces of 1 and try to make a rectangle? So I have brought it along the length of the rectangle above, but then I see that this side is x, but here the side is not x, because I have now subtracted the minus 2x's. So what is that side? That side is x minus 2, because the side of x square was x, and then these two were minus 1 and minus 1. So it is x minus 2. So now I need to have x here to be able to remove this x. So I already have x minus 2, and I need to have 2 more here. So what will I do? So the 2 pieces of area 1 will help me in this. So what I do is I move those 2 pieces here, and now if you see, this side of the rectangle has become x. So now can I remove the minus x? Right. So there I have removed the minus x from there. So now the final area which I have is this area, which is a rectangle. So one side of the rectangle is x minus 2. What about the other side? It is x minus 1. So what do you think the factors are? So the length is x minus 2, the breadth is x minus 1. So the factors of x square minus 3x plus 2 are x minus 2 and x minus 1. Interesting, right? Now let's see if we can apply our technique to this example. So if you remember the technique, what do? We take the coefficient of x square. The coefficient of x square is 1 here, and then the constant term, and we find the product, that is 2, and we find 2 factors of this product such that it gives us the coefficient of the middle term, that is coefficient of x. So which are those 2 factors? So 2 and 1, and you might be surprised to see minus 2 and minus 1 also. So since negative signs are involved in these expressions that we are dealing with, we would be required to consider minor factors which involve minus signs also. So which 2 factors give us minus 3? The minus 2 and minus 1, right? Because if we add minus 2 and minus 1, we get minus 3. So now how do we solve this? We take x square minus 3x plus 2 and then split the middle term as minus 2x and minus 1x. And then we take the first 2 terms as one group, find the common factor in them, which is x, leaving us x minus 2. And in the second group, we have minus 1 as a common factor, leaving us x minus 2. And in this expression, we have x minus 2 as common, leaving x minus 1. So x minus 2 and x minus 1 are the factors of x square minus 3x plus 2. So it's quite easy using technique, right? So let's try another example. We are now to find the factors of x square plus 2x minus 3. So let us first do it using the practical method. So we need one piece of area x square, 2 pieces of area x, and 3 pieces of area 1 which need to be subtracted. So we just turn them over. So now how do we arrange these? So if you see, we can connect it here, but what do we do with the 3 ones? We can remove it the way it has been shown here, but what will we do with this one? Even if we connect this one here or here, we still don't get a final rectangle. So what do we do? Can you think of something? One hint here is that we need an area of 2x. So what are the different ways of getting an area of 2x? Let us see. So we need one piece of x square, and then to get 2x, what I could do is I can have 3 pieces of area x and 1 piece of area minus x. So when I add these two, I still get plus 2x, and then the 3 pieces of area 1 to be subtracted. So now can we do something about this? So I arrange the 3 axes like this. and the minus x, I would arrange it here, and I'm left with the minus 3, the 3 pieces of area minus 1, so those I can arrange it here. So now if you see, I have got this as a rectangle. So now what are the sides of the rectangle? X plus 3 and x minus 1, and these become the factors of x square plus 2x minus 3. So factors of x square plus 2x minus 3 are x plus 3 and x minus 1. We'll try to apply the technique. The coefficient of x square is 1, the constant term is minus 3. So note here that we are taking it along with the negative sign, and then when we multiply this we get minus 3. So we need to find two such vectors which give us 2 as their addition, plus 2 as their addition. So the factors of minus 3 are 3 and minus 1, or minus 3 and 1. So which factors do we choose? We choose the first set, because when we add 3 and minus 1 we get 2, which is the coefficient of the middle term. So this is how we are going to solve it. We are going to split the 2x as plus 3x minus 1x, and then group the first two terms and the last two terms and find the common. So x is common in the first group and minus 1 is common in the second group. Then x plus 3 is common, leaving us with x minus 1. So the factors of x square plus 2x minus 3 are x plus 3 and x minus 1. So if since you already know binomial multiplication, you could multiply these two factors and find out if you get back the expression. So quite simple, right? Let us see if you can solve one example. So this is the example, 4x square minus 8x minus 5. So what will you do? Take 4, take the minus 5, multiply it, you get minus 20. And then find two factors of minus 20. There are various combinations that you can get. So the factors of minus 20 are these different combinations. And which combination would you choose to get minus 8 as their addition? So you take minus 10 and 2. So when you add minus 10 plus 2, you will get minus 8. Then now what do? You would split the minus 8x as minus 10x and plus 2x. So 4x square minus 10x is the first group and 2x minus 5 is the second group. So in the first group, what is common? 2x, leaving us with 2x minus 5, and in the second group 1 is common. And now getting the 2x minus 5 as common, we get 2x plus 1 remaining. So the factors are 2x minus 5 and 2x plus 1. So now I think you have got the technique. So if your quadratic expression involves positive signs, negative signs, you could still solve it using the technique. And the practical method is just for us to get a feel of whether an algebraic expression has any practical significance. So once we are convinced about that, we don't keep on using the practical method for all our solutions. So as the numbers grow bigger and bigger, we would need more and more pieces of the x square, x, and the 1. So once we know the technique, then we don't go back to the practical method. So I hope now that you're confident of finding factors of any quadratic expression. See you again in the next video.